to find the perimeter of a given shape in a coordinate plane, you need to determine the length of the outer sides. In the given figure below, line segment AB and line segment ED are outer sides, and each is horizontal. So the length of line segment AB can be determined by counting the number of units from point A. So from point A, we have 1, 2, 3 units. For the length of line segment ED, we count the number of units from point E to D. So starting from point E, we have 1, 2, 3, 4, 5, 6 units. Line segment EF and CD are also outer sides. Each of these two sides is vertical. To find the length of line segment EF, we count the number of units from point E to point F. So from point E, we have 1, 2, 3 units. To determine the length of line segment CD, we also count the number of units from point C to point D. So from point C, we have 1, 2, 3 units. If the outer side is not a horizontal or not vertical, then we can use the Pythagorean theorem, which is a shorter way of using the distance formula. So we need to complete the right triangle. We start with line segment BC. So we draw a line segment from point B. It should be a vertical line segment, then a horizontal line segment to point C. Using this triangle, we can say that our A is 1, 2 units, and then our side B should be 1, 2 units. So we are solving for the length of line segment BC, and that is our side C of the right triangle. The Pythagorean theorem is given as C squared is equal to A squared plus B squared. If we are solving for C, then this becomes C equals the square root of quantity A squared plus B squared. So the length of line segment BC is the square root of A squared plus B squared. By substitution, your a squared becomes 2 squared, b squared is 2 squared. 2 squared is the same as 2 times 2, which is equal to 4. Then we simplify the radical. 2 squared is 4. 4 plus 4 is 8. So the length of line segment BC is approximately equal to 2.8 when rounded off to the nearest tens. To find the length of line segment AF, we again draw the right triangle by drawing a line segment that is vertical from point A, then horizontal to point F. So this is now the right angle. From this given figure, our A is now equal to 2 units. Our B is only 1 unit. So we are solving for the length of line segment AF, which is our C in this triangle. So the length of line segment AF using the Pythagorean theorem in this triangle is the square root of A squared plus B squared. By substitution, A squared becomes 2 squared, B squared becomes 1 squared. Simplify, 2 squared is 4. Since 1 squared is equal to 1 times 1, which is 1, then 1 squared should be equal to 1. So the length of line segment AF is equal to the square root of 5. Therefore, the length of line segment AF is approximately equal to 2.2. So we now have the length of each side of the figure. We do not need the length of line segment FC because it is inside or in the interior of the polygon A, B, C, D, E, F. So the perimeter, therefore, of the given shape is equal to the length of line segment AB plus the length of line segment BC plus the length of line segment CD plus the length of line segment DE plus the length of line segment EF plus the length of line segment FA. By substitution, AB is 3, BC is approximately 2.8, CD is 3, DE is 6, EF is 3. AF is 2.2. So the perimeter now gives 3 plus 2.8 plus 3 plus 6 plus 3 plus 2.2, which is equal to 20, approximately.